We are going to find an explanation for the difference in the pKa of triphenylmethane and 9-phenylfluorine. In both of these cases, the carbon is connected to 3 phenyl rings. But there is a large difference in the acidic strength of this. So we are comparing this proton with this proton. So if I give it a different color, so yellow proton and the green one. So green one is lost easily as a proton as compared to yellow one. Okay, so if I say that higher the pK, the less is the, so this is less acidic, this compound is less acidic, this is more acidic, has more tendency to lose H positive ion. So we'll explore why is it so, although in both the cases the carbon is connected to 3 phenyl rings. Okay, now for them to act as acids, they need to lose a proton. Okay, so let's write down the reaction in which they're losing their proton. So this loses a proton and forms this anion. So this is the conjugate base of the acid shown above. Fine. So this anion is generated where the central carbon is connected to 3 phenyl rings. Fine. On similar lines, we can draw for this one, loses a proton, and what we get is this anion where the central carbon becomes negatively charged because it loses a proton. And a phenyl ring is connected here. Fine. So a negative charge here. Fine. Now, if you compare the stability of these two species, the anions which are generated, say give them the name A and B. If you compare their stability, that can tell you a lot about this trend. So which of them is more stable? That will tell that would be formed more readily and in more amount, which means the acid of that conjugate base would be more acidic. Now, if I focus on A, this one, there are 3 phenyl rings connected to the negatively charged carbon. Similar is the case with this one. But in case of A, what happens is that there are lots of steric interactions or steric strain in the phenyl rings. So if I copy it here, so I can tell you that these phenyl rings, so these hydrogens, they start repelling each other. There's lots of steric strain here. And so is when they come close to each other in space. So this one. Fine. So there are lots of steric strain in this. Because of this, anion's energy increases because there is lots of repulsions in the electron clouds of these. So this anion is unstable. This becomes unstable in this state. Okay. So what it does is that the 3 phenyl rings, these 3 phenyl rings, they go out of the plane. The coplanarity is lost. Go out of the plane, losing the coplanarity, because of which what happens is that otherwise these lone pairs, they can be in conjugation with the ring, so there is lots of delocalization, but that delocalization get hampered to a certain extent, because of which this resonating structures could not be drawn to, like the number of resonating structures would be less, or the extent of resonance is less, the extent of delocalization is lesser, because the 3 phenyl rings, they are not in the same plane. They adopt a propeller shaped geometry like this. They adopt a propeller shaped geometry, and because of which the electrons from the central carbon, it lost its conjugation with the ring electrons to a certain extent, and because of which it is not that much stable. Right? If I look at B, what is the difference between A and B? The difference is this bridge. Because of this bridge, the coplanarity is still maintained, and because of which the delocalization is possible, and because of which the stability is gained, because the greater the delocalization, the more is the stability of that species. Okay, so the greater the extent of the greater the charge is delocalized, like spread out, the more is the stability. The more is the intensification, the less is the stability of that species. So here, these electrons, they can go and get delocalized. Similarly, they can get delocalized onto the other ring. Okay, onto the other ring. And similar is the possibility with this ring. Okay, so because of greater delocalization, B is more stable. B is more stable as compared to A. So if B is more stable, it means this equilibrium is more towards the product side as compared to this equilibrium. So B is formed more readily. How is B formed? B is formed from the reactant by the loss of proton, and that is why this is very much acidic. 9-phenylfluorine is more acidic. Why? Because by losing a proton, it becomes more stable as B. I hope this answers the question. If you have any questions related to this or similar questions, please post them in the comments. I will get back to you as soon as possible. Thank you.